Let's say you're given this diagram here, and the question says, let's say you fire a rifle of mass 3 kilograms horizontally. So set a bullet of mass 5 grams, travels with a speed of 300 meters per second. What is the recoil velocity felt by the rifle? Additionally, what is the final momentum and kinetic energy of the rifle and bullet? To solve, we need to use the conservation of momentum. In general, the total momentum is going to be equal to the summation of momentums of the system, where P is the total momentum, and the summation is the sum of all objects' momentum in the system. So in our two-object case, total momentum is going to be equal to PR plus PV, where PR is the momentum of the rifle and PB is the momentum of the bullet. And so we can note that in general, momentum is equal to mass times velocity. Additionally, we need to find the kinetic energy of each component, which if you remember, the kinetic energy is equal to 1/2 mv squared, where v is the velocity and m is the mass. So we can apply this to our example. This is our example here. We need to find the final velocity of the rifle, denoted by VR. So we start by applying our momentum equation here, knowing that there's no net external force on the system. So that means the total momentum is conserved. The total momentum is equal to 0. In this case, there's no change in total momentum from firing since no net external force acts on the system. It's 0 because if we look at the situation before the gun fires, the momentum of both parts, the bullet and the gun, is 0 because they're both at rest. So that means the total momentum is 0, and if it's conserved, it must remain at 0 always. So the final total momentum is going to be equal to 0. If we plug that in, we need to note that we're solving for the final velocity of the rifle, VR. We can bring the momentum of the rifle to the other side, and then we can plug in our definition for momentum equal to mass times velocity. Do that for the bullet and the rifle, we get this expression here. Plug in our known values for the question, the mass of the rifle, the mass of the bullet, noting that the mass of the bullet has to be converted into kilograms to make the units make sense. And we can also plug in the final velocity of the bullet. If we do that, we get this expression here. So we can isolate for the velocity of the rifle by multiplying both sides by 1/-3 kilograms. Do that, we get this expression. We can do a simple division of the amplitudes into units, and we get this final answer here. So this is the recoil velocity of the bullet. Now, the negative side makes sense because when we fire the rifle, the bullet goes in the positive direction. It makes sense that the recoil will push the rifle back in the negative direction. We can also look additionally at the kinetic energies. So the kinetic energy of the rifle is going to be equal to 1/2 the mass of the rifle times the velocity of the rifle. So we can plug in our known values, do that, and compute the amplitudes in units. We get this for the kinetic energy of the rifle. But what about the bullet? Follow the same process for the bullet. So if we plug in our known values for the bullet's mass and the bullet's velocity, and then compute the amplitudes in the units, we get this answer here. So this is the kinetic energy of the bullet. We look at our situation here. Before, we found that the bullet and the rifle systems here, the total momentum is equal to 0 since they're both at rest. The momentum of the bullet and the momentum of the rifle are all equal to 0 in this case. And then in the after situation here, we have the final velocity of the bullet equal to 300 meters per second. Then we can note that the final momentum is going to be equal to mass times velocity of the bullet. Plug in the values, we get that it's equal to 1.5 kilograms times meters per second. The final velocity for the rifle we found is negative 0.5 meters per second. Plug in the mass and velocity, we can find the final momentum for the rifle, which is equal to negative 1.5 kilograms times meters per second. Notice that the total momentum is equal to 0 in this case. If we add the momentum of the bullet and the rifle, we get 0 still. So total momentum is constant, which makes sense. I want to note that the bullet and the rifle have equal and opposite final momenta. From Newton's third law, they experience equal and opposite interaction forces that act at the same time. So that means that their impulses are the same because the impulse is equal to force times delta t. However, the bullet travels a much farther distance because if we look at the kinetic energies, the kinetic energy of the bullet is much larger. Despite having the same momentum and experiencing the same force, the bullet has much larger kinetic energy, and that's due to the difference in mass.